Hello,
Hello,
friends.
friends. My name is Piyaprach Loiha. I'm a student from Electrical Engineering Department.
My name is Supitcha Chaisrirum from Electrical and Data Engineering.
This lab objective is to observe the voltage behavior in the RC circuits, which the source we'll use is the AC voltage source, and we'll measure the output waveform from the resistor and the capacitor in comparison.
To measure DC and AC voltage, we have to construct the circuit like this diagram and use the oscilloscope to display our waveform. I will introduce you to the lab equipment and the lab component. Let's go! The first one is DC voltage power supply. If you want to turn on and off, just click this button. And this knob is to adjust the voltage value. To measure the voltage, you can connect the ground for the black one and the red one for power supply and connect it to the multimeter. V, the black one for ground, and make sure that you use the correct value, correct unit, in this case it's volt. Turn it on 2.5 volt as just like the diagram. And this is AC power supply. We have 0 as ground, 6, 9, and 12 VMS. And move on to our main component, the resistor, with 3.3k ohms. Let's connect the ground from power supply to the resistor and the power supply to AC power supply with 6 VMS. Connect the ground from AC power supply to the resistor. To see the waveform, we need to connect to the oscilloscope. The first one is ground, next one is signal. Let's connect it to the first channel. Connect it. Make it tight. And next step, we need to connect the signal and ground to our resistor. This is for signal, this for ground, as just like the diagram. And don't forget to turn on. And let's see our waveform. First step, you need to click the auto set. And here is it. This will display the waveform and the value of it. You can adjust the position vertically and horizontally left and right, to make it easy to clear and clear to read and count for the division. Move up and down a little bit. And this is to scale up and down for the voltage division. You can see 10 volt, 5 volt. You can adjust it here. And next up, we will uh, choose the DC or AC coupling. You can click the first one and adjust it AC or DC. First, we will click DC, and here is the DC selector. And if we want to see the AC coupling, we can also adjust it. First channel, click the top one, adjust it AC coupling, click it. Oh, oops, try again. Actually, just click the multi-purpose auto set. And here is the AC coupling waveform of DC coupling. Let's see the value of it. At the bottom of the screen, 5 volt is the voltage division. At first, I will show you for the vertical axis and horizontal axis is the same. If we consider as a box, one box have one division, and inside the box we have about 5 lines. The distance between them is zero point 0.2. If we count for the peak to peak, it's gonna be 3.8 divisions. And if we multiply with 5 volt, the voltage division, we will get the voltage about 19.6 volts. And look again at the bottom of the screen, 10 milliseconds. This is the time division. For the period, again, one box per one division. Period, we have got two division. And multiply with time division, we will get the period of 20 milliseconds. Look at the bottom of the screen. You will see the frequency of it is around 50 Hz. AC coupling, the value of it is the same to the DC coupling, but the difference is the position of the waveform. DC coupling is displayed for both AC and DC sinusoid, but AC coupling is displayed only AC sinusoid. As you can see in the red circle, it represents the position of its waveform.
In the second circuit, there will be an RC circuit which we'll discuss about the phase shift. In this circuit, we'll use both channels of the oscilloscope. Channel 1 will be connected to the resistor, and channel 2 will be connected to the negative terminal of the capacitor. Both of the ground will be connected in between resistor and the capacitor. And notice that the resistor and the capacitor is connected in series. Our main components have two components. The first one is the capacitor, which we will use 1 microfarad capacitor. The second one is the resistor. We use 1 kilo ohms resistor. Now I'll illustrate how to measure the capacitance. First, you have to use these two wires. Connect the two probes in the capacitor. In the circuits, make sure that you connect it to the right polarity. Connect them in parallel with the multimeter. You have to change the modes if it's not in the farad modes. We changed to 2 microfarads since we measured at 1 microfarads. This is an AC voltage source which we will use 9V RMS. Once all components are connected, we will move to the oscilloscope to observe the output waveform. The yellow waveform is the output of the resistor, and the blue waveform is the output of the capacitor. Press blue button on the right hand side to adjust the waveform of the channel 2. On the bottom right of the display, it displays invert. Click the right hand side button to activate the invert. This invert function will invert the waveform. After the waveform is in inverse, adjust the vertical position of the two waveforms. It's best to have both of the amplitudes at the same line. To adjust the vertical position, use the upper knobs of both channels. So this will make it easier to make a cross right here and easy to do an observation. And for channel 2, I'm going to pull this up. To be the same level as the first channel. And for the phase shift, you observe right here, right here. And this is 10. This is 10. So 10, 12, 14. This is a little bit over 14. So this should be 15. So we have 15. This is 10 minus 10. And our period is 20. So we divide it by 20. 1 times 360. Our phase shift will be 90 degrees. For phase shift measurement, we have 2 parts to consider. The first part is the time division, which we observe to be 10 milliseconds. And the second part is the division per box. And each box contains 5 dots, which means that 10 divided by 5 is 2. So each dot represents 2 milliseconds. And this is a clearer diagram and formula of what I've done in the video. So here comes to the conclusion and discussion. So, what is lagging and leading? The waveform that reaches its amplitude first is the leading waveform, and the lagging waveform is the other way around. And how does it happen in the RC circuit? The resistor's voltage is leading capacitor's voltage because the resistor voltage is directly proportional with the current, according to Ohm's law. Whereas the capacitor's voltage, in the capacitor, it needs some time to charge and discharge, which such occurrence causes a delay in voltage change, and this causes the capacitor's voltage to reach its maximum point slower. The practical application of this RC circuit lab is to observe how capacitive loads affect the phase relationship between voltage and current, which is crucial for understanding power consumption behavior in AC circuit.